Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Carl Carlson.
Hey, Carl. We got this question the other day that got sent over, and I thought this would be perfect, right? Because I know that you've had plenty of experience in maintenance reliability and factories and, facilities types of stuff, but a healthy dose of the product reliability side, which is where I think you got your start at GM, was more in product design, testing, that kind of stuff.
That's right.
Okay. So the question's from Anna. And by the way, we really appreciate getting questions, and we love it when you join the conversation. But this was, I thought, an excellent question. So Anna said, I've been a product, I'm paraphrasing, I've been a product reliability, doing warranty, failure analysis, design related stuff for this product. And she said, recently, recruiters have been reaching out to me with positions that are in the maintenance reliability world, in the asset management side of the world. And it wasn't clear if it was in facilities or factories or whatever, but it was more maintaining equipment rather than designing a system or a product. And I thought her first comment was, do they just not know the difference? It's just, at least they're not asking, when I read that, I thought, well, they know enough not to send me site reliability engineering stuff for website, and database durability, resilience and stuff. And I thought, well, that's an interesting question in itself. But then she went on, she said, or am I missing something? So I know that there's some differences, but can you translate the product reliability experience to a maintenance reliability world? And I suspect we could also talk about going vice versa. So her last line was, am I missing something by not taking these requests seriously? Just something to that effect.
Yeah, that's a great question. That's a really insightful question. And it opens up some different topics. The subject of recruiting is something I have familiarity with. I'm a certified recruiter and did a lot of engineering recruiting when I was a GM. Mm-hmm. We would go to different campuses and also and recruit, obviously, people who were experienced beyond college. And that's the subject of a whole podcast itself, which mm-hmm. is how do you structure your career if you're going to interface and interact with recruiters? How do you do that? What's the opening? What are they looking for? And so I'll include some of that in my responses to Anna. But I also want to talk about I think we first need to talk about the differences between product reliability and asset maintenance, and what are the similarities and what are the differences. So let's chat about that first, and then we can characterize that as how do you broaden your career opportunities if you have one or the other. And so I'd like to begin the answer with RCM, reliability centered maintenance, mm-hmm. which is a body of knowledge in itself, and it focuses on equipment, and very nicely the RCM literature and books and Maubrey's book and as well as the standards begin with isolating the vital few equipment systems and subsystems. Mm-hmm. In other words, it doesn't say let's get a maintenance plan on everything. Let's begin with the most important, the most critical systems and subsystems, and that's useful and very analogous to product reliability. Then, interestingly enough, one of the core tools is FMEA in the maintenance world, but it's a version of FMEA. We can call it a maintenance FMEA or an RCM FMEA or supportability FMEA, depending on what the purpose is. But it takes the system that you've identified or the subsystem, and then does a modified FMEA. By modified, I mean, there are some different worksheet columns, mostly the same, but a few different. And then the effects column or the effects concept is very different. And that's one of the things to learn is what are the consequences of a failure? And you have to trace that to, is it evident or not evident? Is it environmental or operational or economic? And then from all that, with your different logic, you end up with the causes, and your recommendations become your maintenance plan, or your predictive maintenance, or your conditions-based maintenance, or the maintenance strategies. And those can be, run to failure, or they can be planned, scheduled maintenance. And it all depends on the results of the FME. And occurrence is very important because that's severity is important in occurrence because the likelihood of the problem and how severe it is will help determine your strategy. So there's a lot of correlation between the knowledge you have on products and the maintenance world. But I strongly suggest to Anna that, or to anybody else, that if you're steeped in product reliability, that you learn in some way maintenance strategies in the maintenance world, study the standards, and very good SAE standards on RCM that you can get by searching the internet.
Well, or search Accendo reliability. There's
or
a handful of people that write nothing
course.
about it, RCM.
Yes,
so.
That's right. That's right. And get balanced in your knowledge, because then I think, to get back to the original question, once you understand both sides and how they integrate, you're in a better position to accept interviews for the either product or maintenance and asset. And so I think the answer is very positive. To Anna. What are your thoughts?
Oh, yeah. And you touched a couple of the similarities with subtle differences to it. And what's the same is that whether it's a product development team or a maintenance team, is that the priorities will depend on that particular group and culture. It might be throughput in maintenance, or it might be quality of the product going out the door, or it might be just uptime, or minimizing cost. But there's the similar range of variables in product development. It could be time to market is critical, or the underlying cost is critical, or the quality of the product is critical, or what it can vary dramatically. And so it's part of it is understanding what is the in any organization. So I think this is similar. It's just a different suite of things. And there's subtle variations in the language that's used. But the basic idea is, what are the critical few? What's important? What's the data tell us? What are our options for doing this? And the better teams I've seen in the maintenance reliability world, they get involved with the design and modifications and in creation of the systems, of the equipment they have. They get involved with the development teams and the design teams from their vendors that are making their equipment, and designing out failures before they even get on the shop floor. And so it can span a huge range of things, everything from straight just do the data analysis to that feeds into an RCM program, for example, or it could be working with design teams. And so it can really vary.
Yeah, very much so. And we talk a lot about in our reliability management practice about supporting decisions. And the decisions in maintenance are different decisions. And that's why than the decisions in product development.
Yep.
So, for instance, a project I did was on a submarine for the Navy. And you have to decide, are you going to try to maintain the equipment while you're out on a mission? Or are you going to try to, or can you wait until you're in dry dock? Mm-hmm. And that's not an easy decision, but that's a decision that has to be made. And so the types of decisions you get in the maintenance world are different than the decisions during product development. And I think a practicing engineer needs to understand that.
Well, I don't know if it's all that different. If I'm designing a submarine, that same question comes up in the design, or I'm making a printer. Is this going to be something that's repairable by the customer, the end user, or by a trained technician that's, say, in a print shop type setting, or do they have to send it back? Is it repairable at all? Is it the price point such that we're just not going to make it repairable? It's those decisions about maintainability are, depends on the product, of course. A car, for example, as I think, Carl, you know something about these, there's decisions all through the design process as well. How do we repair this? How do we maintain it? What level of support or specialized equipment or tools or knowledge is required to change the oil, for example?
Yeah, if you do it right, I completely agree. And that's the problem. Therein is the rub. Is oftentimes the serviceability is an afterthought, and the
industrial design takes charge, and
the maintenance technicians grumbles. Why do they make it so hard to get the starter motor removed? That kind of thing, and so we don't always do that. But you're correct that we should. So you're designing not just for the customer use, you're designing also for the repair and maintenance, and all of that should be part of design. Oftentimes it isn't. In other words, your job in maintenance might be, okay, this equipment's been in process for the last 10 years, and we don't have a lot of opportunities to change it, but let's develop the best maintenance schedule.
Yep.
And so it can be on both sides of that, and I completely agree. Ideally, it's during product development. I want to mention one other thing, which is on design, is design of equipment that builds things is very much a product design skill, even though the equipment is used as part of assembly and manufacturing.
Yep.
And so there's that amount of transfer. One other thing, and I have to say things before I forget them sometimes, is the level of detail. So you and I talk a lot about, not just us, but our field talks a lot about failure mechanisms.
Yep.
So during product development, it's really important to know failure mechanisms so you can make sure that those mechanisms don't interrupt the use of the equipment or cause the equipment to fail. And so you design the equipment so that those failures don't occur. Now, in maintenance, there's that level of detail isn't sometimes available. So the cause, for an instance, in a DFMEA, design FMEA, may be down at the level of root cause and failure mechanism, whereas the cause in a maintenance FMEA might be what we call maintenance actionable. So you have some system that uses a pump, and you're going to swap out the pump. Yeah. You're not going to repair it, in which case you don't go deeper.
Yeah. Well, I think it's because it's oftentimes, not all the time, but many facilities or factories want to get the line running again, because that's when they're making money. If the cars are coming off the end of the production line, they're making money. If it's down because some robot or pump's not working, let's not figure it out while the line's down. Let's swap it out and then go figure it out later.
Right.
But the root cause analysis and understanding failure mechanisms it still is important, because why did that pump fail? And, if I've got 400 of these pumps scattered through our production line, I really want to know how I can avoid the next one taking the line down.
That's right.
So it's you get to know bearings really well. That's what I found in my factory work. Bearings and motors. You get to know those pretty well. And a lot of it goes to, did you install it correct? Do you have the right equipment for that application? This is all very similar to what we do in reliability in any field. Is this appropriate? Is it set up correctly? Is it the right application and right environment? Are we solving those problems? And then it's in a maintenance setting, it's dependent on what the priorities are. If we can take the line down and do detailed failure analysis, well, then do it. Oftentimes that's not a luxury.
Oftentimes it's not. And so in many cases in RCM, reliability centered maintenance, you work at the maintenance actionable level. But then there's the subject in the last 10 years, particularly, sensors have become more and more prevalent and cost effective. And so you can
And
do
a source of failure themselves.
Yes, indeed. That's right. Don't forget that. And there's this whole body of knowledge called predictive maintenance, where you can measure vibrations and you can measure temperatures, and you get in the subject of prognostics, where you can start predicting when something will fail and make sure you maintain it so it doesn't disrupt the activity.
Yeah.
So there's a lot to this subject. Going back to Anna's question, so we can explore that while we have time. The I think a really good product engineer, if you want to explore opportunities beyond straight product engineering and get into the maintenance world, then it's worthwhile to take some of the to start studying, like you say, Fred, on Ascendo reliability, and just start immersing yourself in reading articles and maybe going to webinars, so you know the language and you know the applicability, and then you see for yourself how it translates. Because the thing you don't want to do is get into an interview and then somebody says, okay, so here's the scenario, what would you do?
Right.
And then you get flummoxed and
or they whip out a bunch of acronyms on you, like RCM, if you've never seen that before.
Yeah.
What's that?
Would you run to failure, or would you do predictive, or would you do scheduled maintenance? And you go, oh, you know.
You got to know the language.
You got to know the language, and you have to have done your own thinking through to get the concepts of how they apply on both sides. Then I think, here's more of a detailed thing, but I think you can adjust your resume and your career plan to adjust to both, or to be suitable for both opportunities.
Yeah.
Because I know how this works. Every what do you call it? The OEM or somebody that's recruiting is using some type of AI or some type of algorithms to sift through the candidates.
Right.
And so they're going to want to see that your presentation and material, or your summary, or your resume has the right words in it that at least means an opportunity for interview.
Well, one of the things that, and I think I don't know how I got into the maintenance role. I mean, my first role was as shift supervisor on a plant and then manufacturing engineer. So I started my career in a factory. As a reliability engineer, a good amount of my work was with vendors and their production facility. So I was qualifying lines. I was working with teams to make sure that their processes were set up. My focus was so that we get good products at the end of the day and that we minimize yield loss, right? We make good stuff right from the start. Well, that has to involve the equipment they're using and the techniques they're using to maintain them. I was in one factory, and they had like a 1 millimeter shift they needed to do with this thing. And this guy pulls out a sledgehammer and whacks the side of the equipment. And like, okay, well, I don't think that's the right tool for that thing. Just because you got a hammer, and kind of thing.
Now I got to tell a story similar. Back in the 80s, I was in door testing, but I also went to the plants to see how they adjusted doors, that type of thing. Mm-hmm. And I learned that one of the tools used was a 2x4, and you can open a door, and this was many of the automotive plants back then on the different automotive manufacturers, but you want the door to hang so you have a similar opening all the way around.
Right.
So
the
visually
little seam.
appealing.
The seam is like 2 millimeters or
3 millimeters, something
whatever.
like that.
It's all consistent.
It's consistent. And that's an artisan. And so you get the door and you hang it, and it's not quite right. So what do? Now, of course,
get your hammer out.
Yeah. Well, the right answer would be, let's design it right. Let's do our, Monte Carlo analyses and tolerance studies so that when you install the hinges, the door does hang. But before we did that, in other words, back in the 80s, mm-hmm. there was this thing called door adjust. And one of the tools of door adjust was you open the door, put a 2x4 in between the door panel and the hinges, and then you just start closing the door a little bit. Depending on where you put that 2x4, that door could actually raise a little bit or drop.
Mm-hmm.
So you're actually yielding some of the material slightly. So the question becomes, should that be a maintenance action or not? Or do you go back and insist that people design hinges and doors so that your maintenance action is basically an installation,
Right.
and you don't need to do it. You basically work yourself out of that job. So I just want to share that there's nuances and lots of stories, and maintenance people tend to be steeped in stories. And if you're going to apply for a job, you have to interact. You have to have enough knowledge about the maintenance world so you can talk intelligently about what is done, not making up things.
Yeah.
Because your stories have to be real, but at least searching your background to where you can talk intelligently about both worlds.
Well, that comes in handy when you got a warranty issue and you trace it down to the subsystem in your product that a vendor is giving you, and almost everybody then sends the people out to check on their facility and walk their line and do all this other stuff. You can get factory and maintenance, but be curious, ask questions. How do they maintain this? I was in one plant in Mexico. This plant, you could eat off the floor. It was amazing. And the 20 minutes at the end of every shift was everybody. I mean, the entire facility stopped what they're doing and cleaned. They cleaned windows, they cleaned openings, they wiped down equipment, they swept any debris away. The place was spotless.
That's impressive.
And their yields were very, very high. Their product quality was very, very good. It was such a well-run facility. It was the only one like that I saw. I saw a really kind of dingy, dark one.
I've seen a lot of dingy, dark, and dirty.
But this one was an old Bell Labs facility, also in Mexico, and they made the old rotary phones was where they got started. And then they made the electronic, based phones and push button phones and stuff like that. And they weren't making phones anymore, but they were making circuit boards. But they had quality control and SPC and process integrity and empowerment of the operators and the maintenance teams. It was miraculous. So it kind of threw me into the doubt. It was the same trip. One was spotless and they made really good products. Another one was it just wasn't well lit. So it looked dingy, and they cleaned the parts that were important, but the floor was littered and stuff like that. But they made amazing parts.
You're reminding me of my first job out of college. Was R&D of navigation system gyroscopes. Mm-hmm. And gyroscopes are assembled in a clean room. This back then, the very, very small gyroscopes, smaller than your fist. And they're assembled in a clean room. To go in the clean room, you really have to be clean. And you're wearing a gown, and your hair is covered in a net, and there's super duper HVAC systems. And because the contamination was a huge issue. So, yeah, you just reminded me of that story. It doesn't fit totally into our podcast here.
We certainly can come back and talk about the recruiting one. We have to add that one to the list, because part of it is being knowledgeable and understanding the language differences. But so many of the processes, from FMEA to root cause analysis to data analysis, all translate very, very well.
They do. The methods translate. And that's the thing to learn if you're going to straddle in terms of career opportunities. You need to learn the common methods and then learn how they're applied in both sides so you can talk reasonably intelligently about it. If you are a listener and you're on the maintenance side and have some ideas or stories or questions about opportunities on the product side and vice versa, we'd love to hear from you, because I think there's more to this subject. There's a lot of possible opportunities in crossing bodies of knowledge.
Oh, certainly. And you can do that over at accendoreliability.com/go/SOR. And there you can find a widget to leave us a voice message, or you can leave us a comment. And you can find Carl and I and the other hosts of the show on LinkedIn or on our About pages. Plenty of ways for you to get in touch with us, and we'd love to hear from you. So with that, Carl, I'm gonna go look at my car doors, see where the 2x4 marks are.
Yeah, I'm going to maintain my tea.
There you go.
Okay.
All right. Talk to you later, Carl.
Talk to you later.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.